Hello everyone and welcome back to this video. Today we are going to do something different. I would like to give you a short overview what you can do with machine learning. As a heavy disclaimer, I'm not an expert here. I only have some limited knowledge, but I think there is something I can give you to help you to at least get started and some insights. So without further ado, let's dive in. So there are some things we need to set up first. What we need is Python. Python is something you can very easily download at this link below, install it. It works on Linux, macOS, and Windows. Then you need pip, that's the package manager. That's specific for every platform, but I think you will find the instructions. With pip installed, we need to install a bunch of libraries. That's this command. You can execute this in the terminal if everything is working. And it gives me that everything is already installed because I installed it. From that point on, you could basically work with every editor to work with Python. I'm using IntelliJ here. With IntelliJ, what you need is a plugin. And there is a so-called community edition of Python that you can use. And then you already have very good support for Python for free. And if you have a new project, of course, in IntelliJ, you need to tell IntelliJ that this is a Python project. So SDK is here, Python. And that's it. And then you're already good to go. This is pretty easy to set up. Okay, so one of the first examples you usually start with is a so-called iris example. So this is basically a flower with several characteristics, which are called sepal and petal width, which are basically the lengths of the blossom. I found this example already very, very complicated, as I am a stupid Java developer and I know nothing about all of the stuff and mathematics. So I found this unnecessarily complicated, so let's get rid. And we will start with a simpler example. Every time when we start with machine learning, and this is the first discipline, which is called supervised learning, which basically means we give the machine data and train the machine. There are other disciplines, but this is the first one. The easiest one is we need input data. And for this example, we just take body sizes and what do they mean? So you see here, we have some sizes, 50, 60, 70, 90 centimeters. And these are normal length from a human body, and they usually equal to a classification, which is until 90, we can say this is mostly a baby or a small child. Then from 100 on, we have a child, and from 150 centimeters, we have an adult. So this is the data we basically feed into our machine. So let's take a look at our source code here. That's everything we need. So what we need is a library that's called pandas, that's doing that's reading in the file and giving us some very important functionality that we can work with this later. And we need scikit. Scikit is one of the options we can use to do machine learning here with Python. And that's mostly it. This will read the file. This will train it. And then we can also do a prediction down here. So let's run the program. So what we are doing here, we say, please give me a prediction what 180 centimeters will be. And as we see here, it already says, yeah, 180, that should be an adult. Let's modify this. So we go to, for example, 50, which should spit out baby, and it does. So remember, these are the body sizes. And now if we put in 120, we will get child. Of course, we can be a little bit more explicit. We can also say 124. This also works. And we can also go beyond the barriers here. So this lists end with 200. So if we do 210, this still spits out adults. So because if you take a look here, there is the question, does this make sense? If a normal application, we can have some very basic if commands, which would just say, if the size is between 50 and 90, we will have baby. If the size is between 100 and 140, this is a child, and so on. But this is a nice thing here about machine learning. We don't have to put in these commands in here. The machine can learn this by itself, and it can then also, it's also possible then to have values that are not part of the list and not part of our commands we put in. Let's take a closer look here. What we also see is we have a so-called train score and a test score, and they are both 1, which is the best that we can get. So usually if you have data, you have training data and you have test data, and a score of 1 basically means the data is perfect. It can be perfectly used for training and for testing. If you run this thing multiple times, you will see that the scores changes, so there is some random things going on. Let's take a closer look, because that's at the first glance the only things that you need to do this stuff here. So if you're not familiar with Python, that's not a big deal, honestly. I wasn't familiar with Python easy at first, but it's pretty easy stuff. So what I already did here is to have some functions here to divide up the code a little bit. So what we are doing here is we read in the file, and this will return the file via this Panda, which is a library, again, for file processing. The return file will then be put into the train.me method. And let's take a closer look what's going on here with the debugger. So you see this very funny notation here. This is not too complicated. So what this basically means, the Panda library reads in the file, and if we use this notation, which is basically coordinates, this basically says, give me the first row, which will be size, and this says, give me the second row, which is basically the type. And that's it. And so we can divide this. So we will see here, these are all our sizes as an array, and these are all our types as an array. This is something you need to get used to, because if you're a Java developer or a C# developer, you would usually process files in a different way, but this is the way it works here with machine learning. They are separated into arrays and then fed in. What we then do is we call a method that's called train test split, which with this option here, 0.4, which basically divides the data into 60% training and 40% test data. And then we need a so-called classifier. I won't go into too much details here, but this is needed for the training data. And this classifier is the most simple. That's the so-called nearest neighbor. You might know this from something like image processing. So nearest neighbor, if we make an estimation later, it just looks what is the nearest data from my input. So for example, if we would input the 154, it would take this set of data. If we would use 162, it would use this. So we are using this classifier. Then we actually do the training with values train and target train. And then we can put out our score here. Return the classifier, and then we can do our prediction now with the 210. Yeah, and it works. And that's mostly it for this very simple example. So now let's have a little bit more complicated example. Oh no, that's something I forgot. Just to stress it, it's very important to have very good test data. So our body sizes here, that's already somehow okay. But it has 17 entries. So if in contrast we use a much shorter list like this, which only has 3 entries, basically everything will go to hell. And I'll show you this in a moment. So we just say body short. And now we do a prediction, and now we say, oh, 210 centimeters, that's a baby here. I don't think this is correct. Or if we say 150, if I say 150, I still get a baby. So this is the thing here. If we do supervised learning, it's very, very, very important that we have a good set of data, a good amount of data. So obviously just 3 entries isn't enough. And the data also needs to be good. There should be no errors in here. And so what I already learned is it's less about understanding everything. It's more about preparing a set of data that's actually good. So if we now go back to our original test data, that looks much better now. So 150 should be an adult, as 160 and 120. Yeah, looks good. Okay, then let's hop into a more difficult example. So with this list, with our original list, we basically have one source value and one target. Let's make this a little bit more complicated. We now want to predict something like TV prices. For this, we have a list that looks like this. This is comprised of month, the initial price, and the price after this month. So for example, if we start with this very expensive TV, it costs 640.49. And as the time progresses, for example, in month number 4, of course, the initial price is still 640.49, but the price drops to 53.999, and so on and so on. That's the first TV. Then we have another TV indicated here with a starting price of 189, and you see the progression here. And we have another one that is much more cheap, like this one with 599. And for example, we see this TV will drop to 529 euros. As you see, there could be some rules that we could grab from this here. So there is a percentage that goes down every month, but we can let the machine do the job here. So I just close the other files for now, and let's take a look into our TV price Python. Funny enough, this pretty much looks already like our body size example. There's not a lot of difference here. So of course we feed in another CSV file, this is called TV price fake because the prices are just made up. I could do some more research, but I just put some random numbers here. And other than that, it's very, very similar. So let's run this program. I made some more predictions here. So we have a prediction here for a TV after 14 months, and we feed in the initial price. So this is our source data, month and initial price, and it should give us a prediction. So let's take a look. So with 599 after 14 months, we can take a look if this is correct. Let's close this file also. So as you see, there is no 4,599. So the nearest neighbor will obviously use one of the data sets with 6,499. And there's also no month 14. There's only the 12. Yeah, and it gets this price. Of course, this is not totally correct. So the machine is making an assumption here that after 14 months and with this price, which is similar to this price, we get this result. Another example, 14 months and 2,599, we get 120.49. Yeah, so the machine this time took data from here with the TV set that is 189 euros. Also again, after 14 months, so it's choosing less data sets. And our third example is 620. after 6 months. So this should, of course, take the last data set. The last data set, 680, is much nearer to 599 than to the other ones. And after 6 months, we should get 549. But we get 579, which is this one. Yeah, okay. Good. So that's so much for now. Thank you for your attention. I hope I could give you a very first impression on how to do this, and I hope to see you on the next video. Bye.